G'day. So I would like to start off by congratulating Surgey for the awesome work that he's done in finding this method. I'd also like to thank all those around the world that have been working on a solution but haven't found one yet. There's a lot of people out there that are giving up their time and resources for free to try and find a solution to benefit all of us. So thanks to all of you that were, doing your bit and having a go. So where I'd like to start is with the things that you need to actually carry out this process. Firstly, you need to be confident at soldering. If you can't solder, you're really going to struggle with this, and rather than damaging a board and then having a board that's no good, you might be better off going to a repair shop and saying, hey, look at this video, what would you charge to do this? The other thing you need is a right motorboard with an SD slot on it. So there's the SD slot on this one. Not all of them have it. In fact, I believe less have it than those that do. So that's something you need to check as well. If you don't have one, you can look to add one to the board, but you might be better off, rather than trying to put one on the actual board itself, just like Surgey did, you could look to just tag wires off the board to a unit. And that might be a little bit easier to do. Obviously you need an SD card to put the software on. You need to download the image as well as the program to write to the card. In relation to your soldering iron, you're going to want something with a fine tip because the stuff you're working with is quite fine. You'll need some solder. You'll need a ferrite bead or a 1K resistor, and there's a couple of ways that can be configured. We'll go over that later. You'll want some fine wire for jumpers and stuff. You'll need a USB to serial adapter, and that's used to connect into the J2 UART port. And you then load Putty up and you can see what's going on with the board. I would also recommend solder braid, especially if you're looking to surface mount one of those ferrite beads or a surface mount resistor onto the board. You might just want to clean that up before you do it. The other thing that I would recommend is flux paste. It really assists when you're soldering things. It really helps to get that heat into the item rather than just burning away at things. Personally, I use a magnifying glass that's lit on a stand because my eyesight's pretty bad, so depending on how well you can see, you might need one of those or not. And also just be wary of anti-static precautions. Last thing you want to do is, shock the board with a whole stack of anti-static and you kill the board. Righto, so let's just talk about the board orientation. I'll just draw it up on the board for you just to give you a rough idea. This might actually end up being reversed in the video. We'll see what happens. So basically, whenever we look at the board and we talk about the top of the board and the bottom of the board, the top of the board is the gimbal end. I think I spelled it right. And the bottom of the board is where the battery connects in. Okay, so that's your orientation. We talk about top, we talk about bottom. So obviously this is left and this is right. One of the easy ways to the left-hand side of the board is it actually jots out on this side a little bit, where you've got your connector that goes down to the compass and other components that are in the landing gear. Just to talk about the board a little bit. So the video processor is right up the top here near the gimbal. It's in a, it's just a shield. So it's got a cage around it, it's got a lid on top of it. Inside there, there's the DM368, which does the video processing. And then there's also the NAND chip. And there's a couple other chips in there, but they're kind of irrelevant at this point. So there's also a JTAG adapter on the right hand side about there. Down the bottom here, there's another processor. So this one does all the video encoding, and this one does all your flight control and all the other things that are going on. There's a separate UART port to plug into it to see what it's actually doing. And they are running different operating systems as well. So this one's actually a STM32 from memory. And its UART port's located about here. I forget the number of it. But the one we're interested in is up here near the actual DM386 processor, 368 processor. I always get it mixed up. And this one's actually labeled J2. So you'll be able to see that. It's just a little 3-pin port. Now, why orientation is important, and when we talk about it, it can be quite critical at times. So when we talk about the J2 connector, which you will plug that USB to serial adapter into, you need to make sure that you get the orientation of the ground wire correct. If you mess that up, you will damage the board. So you need to make sure it's in the right spot. The RX and TX can actually be switched around and it doesn't make any difference. The only thing you'll see is nothing. You won't get anything feeding back into the Putty application or whatever terminal emulation software you're using. So if you connect it up and you're not getting anything in Putty or whatever you're using, the first thing you normally do is reverse that TX and RX line, and that's normally what the problem is. So in relation to the J2 connector, the top pin, so the pin closest to the gimbal, that is ground or negative, depending on what country you're in. And then the other two are TX and RX. I forget which way it goes. I think TX is the top one and RX is the bottom one. Just remember that when it comes to using serial interfaces, if this is my J2 connector and this is my serial adapter, I actually swap those over. So you don't do the TX to TX and RX to RX, you've got to do TX to RX and TX to RX. Because what I'm transmitting here, I want to receive there and vice versa. Anyway, so that's the J2 connector where you plug in your serial adapter. We've spoken about the location of the DM368 processor, we've spoken about the other processor, we've spoken about the JTAG. You may or may not use that for this process, it depends on how you do it. There's two other things that are quite important to this. One is called TP1, it's referred to as TP1. We don't actually have the board name because it's covered in some underfill. So up inside this can, you've got your 368 processor, you've got your NAND, and there's two large resistors, and then there's one small one. And I think this is where Surgey's original video confused a few people. I know it confused me because in the video, it looks like he's touching one of the large resistors. He's not. He's actually touching the small resistor above him. And I'll throw up a picture if it hasn't already flashed up, just to make it clear exactly which one we're talking about. You might have some of the black underfill on top of that resistor. You might need to scratch a little bit of away, but be very careful when doing that, just to get good contact. And you want to be connecting to the left-hand side of that resistor. So the other important thing is what's called TP2. It's actually it's FB36, and it's located over here near the actual motorboard connect. Sorry, it's not a motorboard. The motor sensors. So this board, actually, be careful with these boards. They have little switches on them. These little switches get tripped when you fold your arms out so that the drone knows you've folded the arms out. If you don't fold the arms out, the drone won't arm. If you have a broken switch and you fold the arm out, it's not sending a signal to say arms are out, you can now arm. So over near where this plugs in, there's the FB36, and the importance about that is that it is the pad where there is normally either a ferrite bead, which allows power to flow through into the SD card, which is mounted on that board. So with that not being in play, the SD card can't be used. So what we need to do, if you locate that FB36, you'll see there's two pads, and above it there are what looks like a pair of ferrite beads. I think the next one up I think is FB39, I could be wrong, it might be FB38. But those two should already have ferrite beads in place. I did find on one board, and I've only ever seen it on one board, where this next one up was actually missing. So I just soldered another one in, and it was right to go. I originally couldn't work out why I couldn't get the board to work, why this process wouldn't work. And then I noticed that it was missing, so I put one in and away it went. So what you need to do, and this starts getting into the process, what you need to do is you need to bridge this somehow so that the little board's now getting power, so that the SD card unit's getting power. There's a couple of ways you can do it. In Surgey's video, he actually solders, I think it was a ferrite bead or a resistor across that, and then he tags a wire to it. So we've now got power through this resistor into the SD card reader, but we've also got power on the other side of it on this wire. What we then do in a certain part of the process, we then hold that wire onto the left-hand side of this resistor, and then we power the drone on. But we'll get to that. We're starting a little bit ahead of ourselves. But there are a couple of ways you can do this. So you can bridge it with a ferrite bead. I think you can do it with a little bit like a 1K resistor as well, and then you can tag a wire on there. That can be a little bit tricky because there's not a lot of room there, and you're actually quite close to the connector for the board. So that's one way you can do it. What I generally do is where I've got those two connection points, I'll actually make up a wire, and I make it fairly long so that when I remove it from a board, I can cut that bit off and just clean it up and re-tin it. What I'll do is I will get like a 1K resistor, and I'll tag a lead on one side, which I put to one side, and I'll tag a lead to the other side, so this is going to the SD card. But on this side, I'll tag a second lead. And this lead is then used the same as this lead. I use this lead to touch on that resistor to get me in the right boot mode to boot off the SD card. So that's another way you can do it. Another way that you can do it is you can short this out somehow with mounting a resistor on there or using a wire or whatever, as long as you've got something in there. And this is where the JTAG comes into it. When you look at the JTAG port, because all we need to do, we need to get power into this SD card, and we need to apply power to this resistor on one side of it when we go to boot. So when you look at the JTAG, I forget what I think it's just labeled JTAG. I'll double check to see if there's something. I'll drop it about here. JTAG board number. So pin 1, which is left upper corner, is actually 3.3 volts. So what we can actually do, we can tag a wire to this, and this pad is a lot bigger than this pad, so it might be easier. So I can tag a wire to that, and then I can use that as my wire to apply voltage to this resistor. I could also, if I wanted to, rather than trying to solder onto two small pads, depending on how good your skills are, you might actually do the same, solder a wire on here, but branch this off this way, drop a 1K resistor in, and then use that to connect to the right hand side of that FB36. So that's what you need, the board, a couple of ways that you can actually do it. Next, I'll get some hardware together and I'll just run through the process so you can see exactly how it works. The board I'm using is dead. I'll show that to you. I'll power it up. You'll see that the LED stays white, which is one of the known symptoms, and the gimbal won't initiate. It just sits there silly, looking at the ground like a sad dog. Anyway, so I'll do that, and then I will run through the process in one complete video, and then I will show you that all of a sudden that white LED changes to a flashing red, which means that it's loading stuff. There's some errors in the system, but they're to be expected because not all the drivers have loaded. The unit hasn't, been paired. And then I'm not sure whether this drone's actually paired to the controller or not. It might have been unpaired. What we'll then do is we'll look to pair it to show you that it does pair. But as soon as we run the process and then turn it back on again, even though that LED's flashing red, the gimbal will initialize. So you'll see the gimbal swing into place. And we will get it to the point where that LED, once we pair the controller and everything's booted and all the drivers are loaded and everything's good to go, we'll see that LED change to green. So give me a couple of minutes and I'll be back. Okay, so I just really quickly wanted to run over the board and the way I've got it set up before we get started. It's all pretty straightforward. I've got the drone, got the gimbal in, got the battery ready to go, got all my wires hooked up. So this first wire coming in over here, that is to my serial adapter. It's plugging into J2. Down here inside the actual can, I don't know how well you can see it, we've got those two larger resistors we're talking about, and then behind that there's a smaller one, and I've cleaned some of that underfill off that just so I can get a good contact on it. Here is my ARM board, which has got an SD on it. Down the bottom here, you can see we've got that FB36. The green wire is on the side that has the power. The red wire is on the side which goes off to the board. Now, if you look at the wiring, as I was saying before, there's a couple of ways you can do it. I've got the green wire hooking up to the power side. It then runs through a 1K resistor, and there's two wires that come out the other side. One of these wires goes back to that FB36. The other wire comes to this probe here. Okay, so the plan is that what I do is that I use the probe, because it's a lot easier than a piece of wire, to short out that little resistor, and that will then trigger the SD card boot, because that's what we're trying to do. The whole idea of this process is to change the boot select mode from NAND to SD card. Just a couple of quick safety tips. Make sure your props are off. Never work on something like this with props on. It always ends bad. So props off. So in relation to what we're doing, we're changing the boot select mode to SD card. And that is so that we can flash to the NAND a new bootloader. For those of you not familiar with Linux and Unix, unlike Windows where you generally just have one big partition and everything just loads out of that, this is somewhat different. You have a bootloader which is pretty much just a generic boot image that starts off the process. Beyond that, there are a couple of other partitions on the NAND that load other things. Things like your kernels, your file system, user data, black box, all that sort of stuff. There's around about 10 of them, I think, in the Karma, something like that. And some of them are duplicated as well for backup. Righto, so let's get on with the process. Okay, so we're about to start the process. So first thing I'm going to do is I'm going to plug in my serial adapter, and you'll notice that the light comes on to say it's got power. When you're actually using it, transmitting, receiving, you'll see little flashy lights, which means data's moving back and forth. The next thing that I want to do is I'm going to start Putty. I'm actually using a Linux operating system. You can do this on Windows, that's not an issue. Some of the things will be slightly different to what you see here, because this is a Linux version of Putty. One of them is that the device type is different. This talks about dev, TTY, USB, whereas you should just see USB on a Windows device. Anyway, so speed should be 11.5200, and then whatever the device is, that the serial adapter is plugged into. If you can't connect to it for whatever reason, there's a whole stack of information online about how you can diagnose that. If you're on Windows, you generally look in Device Manager and see what your serial device, see what USB it's on. With Linux, there's some command lines. One thing about Linux operating systems is that it's actually case sensitive. So that TTY that's lowercase on my machine has to be lowercase, otherwise it won't see the device. Anyway, I just want to quickly check. Yep, cool, 45 rows, good to go. So let's just open that up. And it's not quite as big as I'd like. And I don't have a mouse on this machine, so it's almost impossible to resize Windows. Because I'm kind of going off. Yeah, 180 is more like what I want. 150 will do. Righto, so let's just plug the battery in and we'll turn it on and we'll show a failed boot. You'll see what it looks like in Putty. As well, you'll see that we get the white LED, that the gimbal doesn't initialize at any point, it just stays there limp. So in Putty, you'll notice that it's tried to boot off NAND and that's failed because it couldn't find the image. And this kind of comes back to what we're doing here. We're just looking to fix that initial generic boot image so that the device will boot. We're not touching any of the other partitions on the NAND. We're not touching any of the kernels. We're not messing around with any drivers, anything like that. It's just that initial boot sequence. Righto. What you will see sometimes, if the drone's on long enough, depending what's happening, the other processors, so the STM32, will actually go into failure mode. And you sometimes, after a few minutes, will see a red blinking LED on the power button. Doesn't always happen, but it happens sometimes. A lot of the time, if you leave it on, it'll just stay white forever. But regardless, either way, you won't be able to power it off through the power button. And the other thing is that gimbal never initializes. One thing to make sure, if you're using another board like I am, that you put some sort of non-conductive material between the main board and that board. The last thing you want is those two things to short out, but that should be pretty much common sense. Righto, so let's disconnect the battery. We will plug the battery in again. And before we power it on, we will short out that TP1 that we were talking about. And what that does, shorting that out, sets that pin high. By default, it's low. By default, all three boot pins are low, which gives it a value of 0, and therefore it boots off the NAND. By setting this pin high, by applying voltage to it, it selects SD card as the boot device. There are other boot options. From what I know of it, what I've been told, the other two boot pins aren't exposed anywhere. They're actually hardwired to ground straight out of the processor, and therefore there's not much you can do with them. So the other boot modes aren't selectable. Righto, so what we will do, using my trusty magnifying glass, so this is now live because I've got the wires in already. And all I need to do is plug my battery in to start with, because otherwise it ain't going to do anything. And I just need to short out that pin. And then when I power it on, what we'll see is a different boot mode. So it's now booting off the SD card. Now, I generally leave the probe on that resistor until I get to the login screen. And at that point, I'll take it off. Shouldn't need to do that. It should be, once it starts up, you can take it off. But yeah, I just leave it on there until I get to that login screen, which we're pretty close to. Righto, we're at the login screen, so I can remove that. You'll notice that the LED is still white, the gimbal hasn't initialized, but we are at a login prompt, so we're now going to log in as root. Root is basically the Linux equivalent of administrator in the Windows world. I know the Unix people will shoot me for that because it's a lot more detailed than that, but that's the basics of it. Righto, so we're now logged in as root. So now what we need to do is we need to run the 4 commands. I'm going to see if I can copy and paste them in, otherwise I'm going to have to type them. So the first one enables the ability to write to the partitions that we're talking about. Let's go copy that. And let's see if I can paste it in. I don't think it's going to give me the ability to paste. Yeah, no, it's not going to give me the ability to paste, so I'm probably going to have to type it out, but that's all right. It won't take too long. So the first one is insmod, and I have really bad dyslexia, so a lot of things get typed backwards. insmod, and the directory is opt sentinel modules, and it's mtd underscore write underscore enable .ko. Let me just double check that, looks good to me. So we run that, and that one has run, and as you can see, it's now listed out all those different partitions that we have, and it's made them writable. So the next command that we need to run is a lot longer, and this one is, so this is going to take a backup of the bootloader that we're going to replace. So we use the command ddnew if equals dev, so if it exists, mtd block 0. No, I didn't know. Block 0. No, there's no. Of equals. Sorry, this will be painful. Back up. mtd block 0 dot bin conv equals sync. So we've got some command parameters on the end here. No error. Status progress, and that's it for that one. So let's run that one. So that's doing the backup. And that's done. Okay, so the next thing we need to do is we need to erase that bootloader from the NAND. So we just do a flash erase all. Dev mtd 0. So that's done that. That's pretty quick. So now what we need to do is we just want to write the bootloader back in. So we go NAND, because we're running to the NAND, NAND write, -p, and this is the location it's going to, so it's dev mtd 0, and we're getting it from home origin / mtd block 0 dot bin. And as you can see, that's now writing that out. Okay, so that's done. So that's the process. From here on in, everything should work. So I'm going to shut down Putty. Actually, no, I'm going to leave Putty up because when we boot again, we'll then see the good boot that we get. So let's disconnect. We'll disconnect the battery because that's the only way to power it down at the moment. And we will plug it back in. And turn it on. And we should see a good boot. Did I miss the button? I think I missed the button. Or I didn't plug the battery in, one or the other. That battery's in. Okay, so as you can see, we have a very different outcome this time in the Putty session. You can actually see that this time it is now booting off the NAND. And you'll also notice that the LED has now gone red, which means that it's looking for components and loading stuff, and that it's not ready to fly yet. You'll also notice that the gimbal has now initialized, the camera's on. And we also have a login screen. So the next thing I want to do is I'm going to turn on the controller. This isn't the actual controller off it. And I want to put it into pairing mode. So I hold down the power button for around about 8 seconds. And I think I just turned it off. That's all right. We will turn it back on and put it in pairing mode this time. There we go. Flashing blue light means we're in pairing mode. As you can see, it booted again. You always see some errors when it boots up. That's normal. Okay, so camera not connected. So let's pair. We're a little bit close to be pairing. But once we get a solid blue light on the drone, that means that it's paired. There we go, we've got a solid blue light. It says to press the button once. I think I pressed it. There we go. It's now flashing green, pairing is complete.
Successful.
So if I swipe up and my camera's inserted properly, it's pretty much ready to go. Yeah, sure, let's go linear. Yep, make sure your battery's all the way in. So if we were to get GPS reception here, because we're inside, it'd start up. But at the moment it won't. I could try and put it in expert mode, but yeah, I'm not about to do that. But yeah, basically that's it. She's done, she's ready to go. If I disconnect it, put the cover on, put some blades on it, I'll be able to fly it. One thing to make sure that you do, well, a couple actually, if you've used another board to do this process, make sure that when you connect your other board back in, that you re-silicon it so that the connection doesn't come undone. I'll show you what I mean. And just in case anyone thinks that that board is actually still doing anything, I should have powered that down properly, but you get that. So I will now remove this board altogether. And
lost connection.
I will now plug the original back in because it won't arm unless it is. You need to be really careful with these connectors. You need to make sure they're in properly. If you put them in sideways, you can cause yourself issues. I'll disconnect that. So this is basically now a Karma drone. It just has those two wires I tagged into it, but they're doing nothing because they're really going nowhere. So if I put the battery back in,
and I power it back on, it will boot up as normal. We will see the camera initialize and swing around into place. The light will go red on the power button flashing, and then it will go green as it pairs with the controller.
Okay, so that's the process. It took me around about 10 minutes. I know there's a lot more other information in there, but I think it's worth watching at least once. As I said before, if you're not confident at soldering, look at what other options are available, whether you go and seek help from an electronic workshop locally somewhere. The other thing is we're also starting a Discord channel. I'll drop an invite below, and it will be a place where people can go and ask questions. We can provide more information, that sort of scenario. Alrighty, so once again, big thanks to Surgey.